How's it going, everyone? Welcome. Jose Gonzalez here again. Today we're going to talk about Generator. This is peculiar concept that it has been around in the JavaScript for a while, since the ECMAScript, which was published in 2015, June 2015. And this is now a behavior that was introduced to the language to help us to solve a particular problem that we have when it comes to dealing with this non-local, it's a non-local, non-sequential reasonability problem. What is this? Well, this is part of the concurrency in our applications, and this is quite interesting because this particular course, which is made up by Kyle Simpson, right? So shout out to Kyle Simpson. What the idea here is to understand is the conceptual and the practical of how we're gonna deal concurrency as a JavaScript developers, because this is now the next level of competency, and this is a call to arms to JavaScript developers to have a strategic and tactical approach when we need to handle our concurrency in our asynchronous programs. So, because of that, we went a little bit of history and the subtle difference between two main concepts in terms of understand and clarify our ideas of the concurrency and parallelism, how now concurrency from the computer sense works, and how we are not parallel, as we might think that we can do multitasking, but at the end of the day we are more like concurrent systems, or we are dealing with tasks that overlaps at a time, cognitively speaking. Because if you see ourselves from the biological perspective, there's a lot of things that needs to happen so we can get our shit together. So because of that, the way how now we handle this concurrency in our applications in JavaScript specifically, that is running on the browser or on a JavaScript environment, for example, Node, how can we can use some of the tools that this platform provide, which is not relevant to JavaScript, and how they have become very, very old-fashioned, and they are not allowed to describe as the true nature of our modern JavaScript applications when we need to handle more and more and more complex structures. And more complex scenarios. So even though that callback is something that you can use to come up and handle this concurrency, we look at callbacks and we also code callbacks and to recognize that it's not that easy, especially in terms of handling concurrency. Look at how we're gonna handle concurrency, read that particular code, and also they are introduced a problem known as the inversion control. Why is that? That we have, because it's a callback, it receives now a function, a set of instructions. So we have two portions of our program, one runs synchronous, all right, and the other is the code that we pass to this callback that we want to run at some point in the future, but we have to pass that code to somebody else, or to put things in control. In this case, to whoever going to execute that code. It's a JavaScript engine, but we don't have control at that moment, right? So because of that, and this is a true issue, because it's generating now trust issues. So we want to now, there's a couple ask questions that come up here, such as, hey, I would like to this function not run too late, too fast, too early, or too early, too late, not fired too many times, not too few times. So preserve the state of your applications. Don't swallow up errors and all other things that can happen along the way. So that's why we have now this particular pattern called is thunk, which is something that way predates JavaScript, and this is around the idea of if you have a function that has everything that it needs to, if you have a set of instructions that has everything that it needs to, it's going to wrap that into a function, okay? And by the time we call it, we get the value out of this, right? So we have now this as a container of a value. So from synchronous programming might sound trivial, all right? So you have now a container that anytime you call that function, you get the value of. And this is something portable because wherever you are in your code, anytime you call that synchronous thunk, you're gonna get that value. So things becoming much more interesting and powerful when we want to now have this function that has everything that it needs to, okay? And by the time that that function has been called at X amount of time, at some point in the future, we want to pass now a callback to retrieve the value. So because this function that has everything that it needs, and after the next amount of time, we're gonna get the value, is in there where we're gonna put the callback and get the value out of that. So this is not this is not as a synchronous programming or a synchronous thunk. So this is huge because now what we have done, and thanks to the thunks, is we have now eliminated time as a concerning factor in our application. We have a serious issue in callbacks, especially of when you need to handle this concurrent or this parallel requests, or in other words, in JavaScript is to call several Ajax requests at the same time, but in this case, one after the another. So because it's fast, because that happens so fast, you can think that it's in parallel, all right? So you're firing up all of these Ajax requests. And we also look at what are the problems that we need to handle. So, hey, do we have this, we need to wait for those, we need to wait for the data to come back, one. Also, we need to reply when it comes and manage and coordinate all of this response, as well as now show them in the proper order that were called. And this is not something trivial to do. we went, if you follow me along with all of this series of videos, that particular go, I can share you that on the description. But the idea here is that all of that kind of coordination that it needs to happen, we do that quite manually. And thunks now provide this particular pattern using closures, all right, where you can now provide this data that you want to track, and anytime you call that function, you're going to now access to this data. What you're gonna is now attach some data to this function, okay? But what's truly happening is that now that function can have access to the outer scope of that. So because of that, and how now thunks allow us to coordinate all of this response and now provide us a nice way of how we can actually is create all of our asynchronous programming. How can we write our synchronous programming in a way that is more like reason about, all right? So this is now the precursor of the promise, and thongs at the end of the day solve that particular problem, the elimination of a time as a concerning factor. However, not the inversion control, because at the end of the day we need to pass a call, but we need to actually put them in control. So promise, which is a concept that comes from this particularly, just to make a quick recap here. So you may wonder, what is this inversion control, right? There is a very nice example by the time that you, for example, if you're working for an e-commerce, okay, so they hire you to now develop this user interfaces as well as connect that to their payment services. So you do all of the mock-up that works as expected, and also now at the checkout, well, you're gonna call is a specific you're gonna call on a specific Jesus, you're gonna fire up an Ajax request for that. But because you now decide to rely on a third-party libraries that is telling you, hey, we're gonna handle that for you, you agree, all right? You now pass down function to there, that callbacks to there. You run your tests, you run your checks, okay, everything went well, right? So now you push your change to the main branch. The QA team actually reviewed that. It works as expected. Pass some of the tests that they have to. Good. Now, all right. Let's move on to the next phase, the next stage, which is it's going to pass through the staging, right? If that works and if that work as expected with this production or this close to production data, all right. So it's going to deploy that. Good. So everyone is happy. So we implement this e-commerce feature as it is. So 6 months later, you are at the bar, or you are in a cafe, sipping your mochaccino, and admiring is the beautiful day that is out there, close to summer, and then you receive a call, and it is your boss. And it is not a casual self. And he tells you, hey, we need this issue that we charge Kanye West a couple TVs in your application, but now he is whining and complaining on Twitter, so now we have to fix this, so I need you to be ASAP. And that was very polite, right? So, well, you go back to the office, in this case to your laptop, okay? They have to deal is a PR nightmare for that. But again, you can say, hey, yeah, because we now can call to the payment providers and refunds that. It will take some time to do that, but you need to actually figure out what went wrong, right? So you go to the code, you expect that, you reach to the logical conclusion that is not in your code, all right? But it's in this particular third-party code that you use. So you went through the documentation, all right? And in the docs, well, they don't say anything about that. So to firing multiple things, that kind of thing, they just have a function that actually do that for you, and then you pass a callback. So now you say, well, this things might be an issue for the third-party library. So you now pick up the phone, you call them, the contact support tells you what is the issue. You tell them that, hey, this is now the particular problem that I have with this function, but I don't see anything documented that mention anything close to firing multiple times and that kind of thing. So customer support writes that to the development team, and the development team now say, hey, we got these tickets. Let's see what went wrong, right? So they actually now do some patch fix. They release that with the new change, and now everything is and now everything works as expected according to them. So you go back to your CEO and you say, hey, now this is not an issue for our side. In fact, that was an issue for these third-party libraries that we're using. So when we call them, they describe. I tell them what went wrong. They raise that ticket, so they actually deploy a fix, and now that works as expected. Any CEO that you tell them, their most likely answer is like, well, you know what, all right. They want to know why that happened. And then you, of course, because you need to handle that situation, you need to handle it because you need to take care of that. So you go back to the code, you do some analysis and heuristics, and then you realize that this is something known as these callback things in that particular code where they call them, and they're making some sort of assumptions to that. And those assumptions is like, hey, well, that this function will not trigger too many times, and they're gonna put now a Boolean flag to do that. So yeah, hey, they fixed that. But what happens if you never call that callback, or if that callback is never executed, or if that callback, or for some reason, if we don't get the value from that, do we have a way to handle that error? And this is some question that QA is starting to ask yourself, and then you decide to pretend. Then you think, well, if I go back slowly and I pretend that I don't hear that, that'll be good, right? That'll be great. So even though the questions remains, and this is now asking to ourselves, if you not only if you know how your tool works, but how you're going to handle these particular scenarios, which is something that happened a lot. This concurrency, and this is why the problems of inversion controls kicks in, because now you're passing this set of instructions to somebody else, in this case to the callback. So you put them in control, and then you now have some sort of assumption here, and this is when you have some trust issue here. So one of the things that Promise solve is that, hey, instead of having to pass some sort of instruction to somebody else, wouldn't it be nice to be or to wouldn't be nice to have this like when you go to your favorite pizza restaurant, okay? In my case, my favorite pizza restaurant. So I walk back to the counter. I ask the lady, "I'd like to have a chili pizza." The lady says that'll be $10.49. I hand over the money, and what I'm expect to get in return, my chili pizza. But that's not what I hand over. Instead, usually you get now a receipt with a number print on it, 317, and this is now the IOU from themselves, from there. So this is now a promise here. This receipt doesn't stop me to think about my wonderful pizza and how this pizza will taste and all of this pizza slice dancing around me. So I'm starving. I'm famished here. You know, I can wait to eat. So then suddenly those magical numbers, order 317 comes in. So I walk back to the counter, receive the hand, and what I'm getting instead is the chili pizza. And I mention this because this particular way of when you go out and ask something, that you start a transaction, and by the time this transaction you are hand over a receipt as a way to now act as a placeholder. So by the time that is done, you exchange these placeholders to get actually is the chili pizza, the value. And this is now the idea of promises. This is interesting because it's like looking at how do we now do stuff in real life. And promise, or this is now an abstraction from this, because promise, after all, is this placeholder around the idea that we need to eliminate time as a concerning factor around a value. And because this is using behind the scenes some of the functional programming concepts, because at the end of the day, a promise, you can think of this as an event listener that you can attach callbacks to this. So now you're going to make sure that this data will be available, that is immutable. It won't fire too few times, too many times, too early, too slow. So we have now this guarantee from the language. So promise give us now this trust when it comes to handle this. This is something that comes from the programming language called E, which was written by Mark Miller, one of the TC39 commit, one of the 39 members, one of the 39 commit members, and where in that language they have something called like feature values, and then we have now this stuff here. So by the time we get this promise, and also how can we use promise, what that represents, and how can we now exchange series of computations, which is known as thenables, right? That this not only represent is flow control, but also data flow, all right? And the thing here is that promise behind the scene is is a monad at the end of the day, and the monad is a programming concept. Specifically, it's a functional programming data structure, okay? Where one of the main use case is that it allows is a model to it's a model for state change. That's something interesting. Like this. So monads are a way to model the state change of a value. And we're not going to dive deep into much because this is not a course about monads and that kind of thing. I also going to talk about that in this functional like JavaScript course, again taught by Steve Keeney, by Kyle Simpson, and yeah. But what we really care about here is that this generator stuff, okay, and how now and how Promise actually solves the inversion control and the callback hell, okay. So what generators offer? What is the value proposition of generators? Well, it's about to solve the non-local, non-sequential reasonability problem, which is something that we still have in Promise, especially when we have to pass a callback, especially when we need to is to have several. We need to define is a flow control in our asynchronous program, all right, and then we need to jump to other code as it is. So, for example, hey, I'm going to handle now this stuff, and by the time that is done, I have these two other stuff that I want to, hey, if this is rejected, I want to now do this, and if this fulfill, I want to now handle this. You know, then things started to become a mess to think about it and to reason about it, and not to mention that if you split that in different models, then you have to do all of this non-local jump as it is. So the value proposition of generators is that we need a behavior in JavaScript that allow us is to have a way to control the flow of a function. Here we go. So what is this? Because we need to understand that function, what functions are. Functions have this fancy concept now as run to completion, which is a fundamental concept because it's I will run all of this set of instructions until the end, so that doesn't mean that stop us from calling other functions, but no one can preemptively interrupt the execution of these functions with something else. And this particular word is quite interesting, preemptively, you know. No one can preemptively interrupt the execution of this function with something else. So multi-threading programming actually now when they allow that two functions to happen, so now they have to deal with, for example, memory, preventing from memory, avoid the memory getting a corrupted state, okay, sharing memory or corrupting it at all. It also needs some concept like semaphores and all that wild things. So we don't have to worry about it, which is a great thing, okay? And despite that this might sound very academic, it's a very important concept to understand. So if generators is not, or if generators are not run to completion, why do we have this behavior? Why we want to introduce this kind of chaos to the language? And this is not to introduce chaos, it's just to see how can we now have a behavior that previously took a lot of work to do that. So that's what we have now, closures and iterators as a way to now keep track the flow of control of a function, where now generators is a concept from Python, all right? And these iterators is now another, is a design patterns that allow us to is stepping through a data set. Okay, so however, generators is a syntax, yeah, just like that. So generators is a syntactic form of a it's a syntactic form to describe state machines. This concept here, this syntactic form, Jesus, this syntactic form of describing a state machines is something huge, because when this syntactic things is like, hey, is this a range of words, is a range of tokens, something that when you started to see now how this machine or large language model actually works, it's like this things or this syntax, which is the arrangement of words, it is the arrangement of words for constructing grammatically correct sentence. Grammatically, which is a set of rules, or this grammar, a set of rules. Let me stop here. Because this syntactic form, okay, this syntactic form of describing a state machine, that is now how we have to head. This is one of the concepts in terms of describing here in syntactic form. This is what actually computer science actually handle that. They're not only mathematician, but also is linguistic, because most of them, they need to create some sort of compiler, some sort of language to actually now make it way much more easier, making way much more easier, okay, making way much more okay, I get it. okay, this is the way how you talk this, okay. I get it. This is the position of the word. This is the position of the mouth. You have to. Oh, right. Oh, interesting. This is the position of the mouth that you need to have, especially when you're gonna talk to this. Oh, way much more. Interesting. Oh, this is another discovery here, at least for me. Is that, oh, okay. So this is the way how you, interesting. So way much more. Okay, that's interesting. That's very, very interesting. So this concept here of the JavaScript generator is a syntactic form. Okay, it's a syntactic form of describing a state machine. Is something that it encapsulates a lot of the things that we as a computer science needs to handle and needs to deal with, the mathematics as well as the language. Okay. Because once you understand this, it's way much more easier to do that. That's quite that's powerful. So this syntactic form of describing a state machine, and this syntax is just the arrangement of words in a way that is grammatically correct to form sentence. And this grammar is the set of rules that it's a set of rules that govern a language that include the system, that include it's a set of rules that govern grammar that include the systems, the syntax, the way of how we rearrange words, the morphology, how we're going to rearrange is now letters in there. For example, like prefix, suffix, and words. Phonology, how that sound, all right? So most of the time, because we are writing is code for computer, or we are describing its language for computers, we barely tend to actually speak that out loud, and it is important. It's very, very important. So phonology, as well as the semantic. So what is the meaning of this sentence? This is quite interesting. This is, again, a lot of people. That's why now university try to sell this particular package to say, hey, if you want to actually, because this is a business, bro. Oh my god. If you want to be the next Elon Musk or Max Zuckerberg, you're gonna build your own social media network, all that kind of stuff. This is what you have to do. But at the end of the day, it's like that's way much more deeper than it is. It's in fact, it's a way of how you can actually talk to a computer. And again, Jesus, oh my God. Well, anyway, so is this syntactic? So generators in JavaScript is a syntactic form of describing a state machines. So for those who are not familiar with the state machines, is a way to have a pattern of series of flows and from one state to another. So from one state to another, to another state, to another state, describing or declaratively and declaratively list all of these transitions. This is important. This is huge, right? This is state machines, because this way of have a pattern, because at the end of that is like, so this way of having a pattern that allows to this way of having a pattern of a series of flows. Okay, this is also known as, you can think of this as some UML, but in any case, this way of having a pattern of series of flows from one state to another, to another, to another, to another, to another, and declaratively lists all of the transactions out. This is something interesting, because this particular concept of describing these state machines, okay, is something that this pattern is trying to implement as a callback and iterators, and it's something that is require a lot of work. So these state machines here, this particular pattern of this way of having a pattern of series of flows from one state to another, to another, to another, to another, to another, and declaratively lists all the transactions out, is a particular pattern that is hard or requires a lot of work to that. That's why we use, for example, iterators and callbacks for that. But now generators make it possible for us to have now this magic key to solve this non-sequential and non-local problem. So pretty much like a VCA or a YouTube, where when you stop a video, when you hit the stop, when you hit the play, that phrase or that freeze into that phrase, and you can wait as much as you want until you press that button to resume. So you can think of generators as this idea of passive function. Okay, it's a function that pauses when it finds a yield keyword, even in the middle of an expression. Something interesting. So you can think of generators as this function that pauses when it finds the yield keyword, even in the middle of an expression, as and waits for that pause state indefinitely until some actors here comes and say, hey, it is time to resume. So so you can think of generator like that, right? So it's like, hey, this is a function that you're gonna get into and this is also what we're gonna see is all of this plumbing to know is the mechanism of how the thing actually works, to truly understand that. So you can think of a generator that is a function that pause and resume as many times as necessary. So while the generator is paused, on inside everything is blocked. It is a local block, not an entire program. So this generator function is a way for us to describe is flow function flow control. It's a way for us to have function flow control. That's the whole point of this generator, right? And when you combine that with asynchronicity, it's like, all right, now we can actually do something interesting. That's what we're gonna do in today's video. Okay, but again, you can think of these generators as these functions that it is a function that pause when it finds a yield word, and it can be even in the middle of expressions, and anything is freeze and pause, and it will wait, for that pause state indefinitely until an actor comes, until some actor comes and say, hey, time to resume. It is time to resume. But this is okay. So let's go to take a look now at the more practical approach. So another thing here is that no one on the outside can preemptively interrupt the execution of this function. And this is what is called cooperate concurrency rather than preemptively concurrency. So in line 1, this function now, when we call this, is gonna return not a function, it's gonna return us an iterator, which is a pattern for stepping through a data set, which is a pattern for stepping through typically a data set. Okay, so for example, the result of the database query, you can step through at time and keep calling with the next function and next function and next function. Again, I need to get into the database as well because I'm not quite familiar with, especially when you now define some sort of offsets and that kind of stuff, right? Yeah, and offsets and that kind of stuff. So, yeah. So when you look at this generator function, it's important to look at them from the inside, okay? Because this function, the TLDR of this generator function is that this is now a function that you can pause the execution, which is this. It's a function that pause. It's a function that pause when it finds the yield keyword, and it can be even in the middle of like an expression, until some actors, until in the middle of an expression, everything is freeze and pause, and it will wait in that pause state indefinitely until some actor comes here and say, hey, it is time to resume. So you can think of generator as this function that pause and resume, pause and resume, pause and resume as many times as necessary. So it is a local blocking and not an entire program. So this generator actually returns an iterator, which is a pattern for stepping through the data. It's a pattern for typically, it's a pattern for stepping through typically of a set of data. So for example, in a database, when you have now this function called next to actually based on a query until you reach to the end. This particular pattern here. So in JavaScript we have our own iterators by hand, and now we can have this concept of iterators is a design pattern, but generators come from Python. And the purpose of these iterators is this, in this case, is not to step through data. And the purpose of these iterators is not to step through data, is through the control of a generator, is through a way of have a function. A generator is a way to have function flow control execution. So we want us to know when these particular lines in this particular function will be executed. Okay.
This is going to feel strange and bizarre to those of you if you've figures before. So just like everything else, what I'm suggesting to you is not in 5 minutes you're going to be an expert on this pattern, but I'm trying to suggest to you, if you trust me at all, trust me that this is where you should spend a whole bunch of time thinking and practicing and reading, because it's going to change everything that we do with asynchronous programming. I'm 100% convinced it's one of the most revolutionary changes to our language. That's why we spend time thinking about it. Okay, so if we can pause a generator while it's running, it's also message passing. So here, I'm not just...
If we can pause a generator,
thinking about it. Okay, so if we can pause a generator while it's running.
If we can pause a generator while it's running, is also a message broker.
It's also message passing.
It's also message passing.
So here, I'm not just calling yield, but I'm actually calling yield with a value. In the previous case, when I showed no value in the yield expression, it was assumed that I was yielding undefined. But here I'm yielding actual values like 1, 2, and 3. And you notice that when I call yield 1, I return control back to line 9 by way of returning a value. So .next returns us an object that has two properties on it. It has a value property with the value that was yielded, if any, and it has a done property that tells us true or false is the generator complete.
The iterator.
So that's why we get value 1 done false. And then we can call .next again right away or at some later time. And we're going to get
now this
value 2 done
is
false.
So the generator now implement is the... so this generator function, generate is a generator that is complying with the iterator protocol and the iterator behavior, the iterable and iterator protocol. And iterable is a way of how you can customize the iterative behavior. So for example, now for off actually make use of this iterative behavior All right. So for example, if you say, hey, perplexity, I would like to now write I would like to alter the iterative behavior of this, right? So generate a JavaScript code that modify the inner iterative behavior of an array of number with the iterable protocol. Because you construct this, you say, hey, implementing the simple iterator methods, right? And then you say, hey, and then you apply some sort of transformation to this, custom iterable. But this is the way of how you can define this, whether it's using a class or not. So here let's go to do this to have a more practical approach here, because it's this, man. Wait, can I have this? There you got it. Is this is, hey, let's go to create now a class to say custom. You say say reverse iterator. But this is if you want to now this is if you want to apply some transformations to this. This is if you want to apply some transformations to this, which is not the same. Which is definitely not the same. Let me see what you interpret out of this. You have your custom array that has now reverse iterator, filter iterator, and running, right? And now this custom array, this is a data structure that you define here. You say, hey, anytime that anyone wants to iterate through me, is this one. What is you want the reverse is this one. If they got the filter iterator, is this one. Hey, if they're the same, okay, deal with that. But again, this is a way of how can we define now is an iterator patterns to do that, right? Default iterator square and even numbers. But again, this iterator is gonna go through through all of these elements down there. But again, this iterator, okay, generate a GS code that modify the inner iterative behavior of an array number with the iterable protocol with reverse. So anytime you call this, you're gonna now iterate is through that. in a reverse order. This is reverse generator. Method to get original array and get reverse, return this. So for example, when you call this, it say, hey, return the iterator object, but now it will say, and it will start from that, from the last position. Exactly. And then you're going to walk backwards or forwards. But this is quite interesting here, because now with this is a behavior that we have to implement before that. That's what happened. This is a behavior that we need to implement is by our hand with the prototype and all that kind of stuff. So for example, we say, hey, a function, Jesus. If we say, hey, I want to create now a function that call is the custom, let's say, reverse array, all right? Exactly, reverse array, where here it will take now the array, all right? This is now using is the old syntax, right? What we're gonna do here is to now follow is, so let's go to store this data here, and then anytime that someone invoke us using the iterable protocol, all right, this behavior of using the for of loop, this is how we're going to respond to that. This is the Iterator protocol. This is how we're going to produce this sequence of data. So it means that by the time that we have this property call here, well, in this case, we can just leave like that, right? Yeah, we define this function reverse as an array. Okay, we can say, hey, this dot array as a private method. Okay, so by the time we call this with the new keyword, it will generate is this new object with the value of array attached to. Okay, but that's what we need to do is this one, right? Okay, and because we are working is with the prototype nature, which is, it's important to understand that that exists. That's one of the reasons why I'm doing this, which is, hey, reverse array dot prototype, which is the place of how you can, in functions put property and methods, specifically methods, right? You say, hey, under the prototype, if you have now the symbol, this one, symbol dot iterator, and the symbol is just a unique identifier to access through this property, iterator, right? I want now to make that function, okay, to not only access to this array, which is something that we're gonna do. So for example, here you say, hey, const index, or in this case, here, let index, that'll be this dot array dot length. Okay, so I wanna get is the last element out of this. We're gonna get the last elements out of this and say, hey, I want you to, anytime you call this, I want you to now produce the sequence of data. And that is, well, the index, and that is this object that'll have the next, okay, there's a method here. That'll have the next, but no, exactly. That'll have is the next here as another function to actually now have access to the lexical scope here. the next and say, hey, here we're going to return is now a value that I will have now the value and the done, right? So this is now the conditions and the value. So how we can make, how do we know this? No. Well, because we're gonna start from, because we are defining is an iterator, it's an iterable behavior. Instead of start from the front, we can start from the end, okay? And this is true for data structure like this, you know? Not to mention that if you have binary search or binary trees and all that kind of stuff, you can also define is another behavior for that. So in any case, here we got is the so here we're gonna get is the value. So anytime you get into this, you're gonna get is the value. That'll be is the this dot array index, all right, at that position, and we're gonna decrement now the index as it is, right? So we also can say here the value will be value. Well, okay, the value will be value, okay, and the down, you want to check if the index is less than 0. So you're gonna return true, right? If the index is less than 0, okay, if the index is greater than 0, you're gonna say, hey, this is true. Keep iterating, keep iterating, keep iterating, keep iterating, keep iterating until this is 0. Yep. Just like that. Yeah, I got some issue here. It's like, hey, is the index is greater than 0? Yes. Hey, is the index is less than 0? Yes. Is the index is less than 0? Wait, what? So if the index is less than 0, this is false because it's because we need to continue to iterate until done is true. That's what happened. Okay, it makes sense. So hey, if this index is less than 0, no, keep going, 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 keep going until you reach to that value. Hey, is this 0? Yes, it is. So not only that we attach this custom behavior here, by the time we call now this reverse array with the new keyword and say, hey, reverse array of this element is like, hey, 1, 2, 3, 5, 7, 9, 10, or 11, right? And then we wanna now console.log is reverse.array and say, hey, I want to now iterate through this using the for of loop. Okay. Like this. So by the time that we now from JavaScript call this iterator protocol, it will do this kind of thing. Reverse array is not an iterable. Wait, what? Reverse array is not an iterable. Even though they're implementing this, reserve array prototype dot symbol iterator. Do I have something wrong here? Oh. Oh, it's because it's symbol. Okay, let me refresh this, and it is Iterator. And now you work, right? So as you can see, we are now getting is this sequence backwards. We are getting is this sequence backwards. We're getting is this sequence backwards, bro. We are getting is this sequence backwards. Okay. So this is just an example of this iterator, okay? An example of the iterator here, and how the iterable allows you to define is a custom behavior. That's the whole point of this. This iterator allows you to define is a custom behavior for that. Let me actually open a code pen here. Code pen. There I go. And there you got it. Iterators with ES6 with prototype, which is this one, right? That's the whole point of this. Exactly. Iterator is a pattern for stepping through a typical data set. The iterable protocol allows us to define a custom iterable behavior. Example. That's what it is. Iterator, iterable here. The iterable protocols allow JavaScript objects to define or customize the iterator behaviors, such as values are looped over the for of construct. Some built-in types are built-in iterables with the default iteration behavior, such as array or maps, while other types of object are not. And in order to be iterable, an object must be implemented in the symbol.iterator methods, meaning that the object of one of the object of its prototype change must have property with the symbol iterator. But it's followed this particularly here. And again, the iterable protocol right, The great thing of this iterable protocol is that we can now have control of how we're going to iterate through these elements, how we're going to step through this data set. How we're going to step in through this database or this data here. This is what iterable protocol, or this pattern for stepping through, typically in data sets. Makes a lot of sense. Okay. Okay. All right. Okay. Good. 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 So keep reading here.
And then we're going to call it again, and yield 3, at that moment, it kind of looks to you visually like the generator is done, but it's not really done. That's why we still get done false, because technically it's paused on that last expression. Even though visually we can look at the generator and say it's not going to do anything else, technically it's still paused. Technically you can still do something with it. So that's why the fourth .next down there on line 13 would resume the generator at the paused line 4. Immediately there's nothing else to do. It would finish, it would complete, and then we would get an object back that there was no value given to us, but there was a done true. Now what about that value undefined? Where do you suppose that comes from? Where it comes from is that in JavaScript, all functions that don't have a return statement imply a return undefined at the end. So there's an implied return undefined on line 4.5. Had we chosen to do a different return value, like for example return 4, we would have gotten value 4 done true on line 13. Does that make sense? So at any point when you do a return from a generator, you immediately complete the generator, and whatever you've returned is sent out as the value. But if you do a yield, the value is sent out and you get it done false. Yeah.
Can we iterate it, like do a for each as like a collection and get the value instead of moving one .next at a time?
Sorry, maybe ask the question.
You're doing it.next and you get the value, then you do an iterator .next, you get the next value.
Yep.
Instead, can we loop through like a for each loop, like a collection?
Can you automatically run through a whole iterator? Absolutely. That's actually got nothing, not specifically about generators. It's any iterator can be run through a loop. You could do your own like for, I loop like that. You could be looking for the done true thing, and then you would know that you're like a while loop looking for done true. But there was a new looping style added to ES6 specifically for consuming iterators, and it's the for of loop. So instead of for or for in, we now have a for of loop. And if you give it an iterator, even one from a generator, if you give it an iterator, it will run the iterator to completion. And it automatically looks for the done false and all that stuff. So if you want to consume an iterator, there is a looping syntax for it. But that's a very synchronous syntax, which may or may not be what you want with a generator. All right, so this is clearly illustrating that messages can be passed out. But it turns out that this is not only a one-way message passing, but actually the yield and the next pair together to create a two-way message passing system. So not only can we yield messages out, but when we call the next method, we can pass a message in, and that message goes into the generator. I'm going to create a little helper for myself, just to save space on the slides. Don't get too wrapped up in what this is, but it's wrapping around a generator. You see on line 2, I'm passing system. Messages can be passed out. But it turns out that this is not only a one-way message passing, but actually the yield and the next pair together to create a two-way message passing system. So not only can we yield messages out, but when we call the next method, we can pass a message in, and that message goes into the generator. I'm going to create a little helper for myself, just to save space on the slides. Don't get too wrapped up in what this is, but it's wrapping around a generator. You see on line 2, I'm executing my generator to produce an iterator, and then I'm returning a function that every time that function gets called, it's going to call the iterators.next, pass in any arguments, and return any value out. So I'm just wrapping up the iterator.next in something that's a little cleaner and easier to illustrate with. But anytime you see the usage of this, you can just think, oh, it's just calling .next under the covers. Okay? So this little helper, I'm going to pass my generator to it, and what I get back is going to be a thing I call run. So run is a function. Every time I call run, it's calling the iterators next. So whenever you see run, just think it.next. All right, so I haven't run anything in my generator on line 1, but I've simply set up this generator to be executed. And on line 7, I'm going to call the first run. That's the first it.next call. And it's going to transfer control up to line 2. Now on line 2, it's going to start to execute. It's going to say var x equals 1 plus, and uh-oh, I see a yield expression. I cannot complete this statement at this moment. So I'm literally going to pause the generator right in the middle of this statement and wait for somebody to resume me. Okay? So that yield keyword is going to return control to line 7. Now that value that came back, the it.next return value that we would see here, would be an object that says value undefined, because we didn't yield anything, done false. Is everybody with me? Value undefined, done false. Had we yielded something, it would have been value, whatever we yielded, and still done false. But here's where I want to tweak your brain a little bit, because this is all about perspective that helps you understand how, or gives you a path for understanding this. What I want you to do is I want you to think about the perspective not from the outside world, because the outside world is how we typically would think about it. We'd think about driving this generator by our run calls. I want you to think about it from the inside perspective, from what's happening in the generator. At the moment that I am on line 2 and I encounter a yield keyword, essentially this yield keyword is asking a question. It is saying, I need some value here. It's like a placeholder that says, I need some value and I don't have it yet. I'm going to wait around until somebody gives me a value. Okay, because I obviously need a value to finish the statement. Does everybody agree with that? Okay, so I'm simply going to pause waiting for a value, and I will tell you, outside world, that I've asked a question. I am asking for you to give me a value. At some later point, like line 8, we're going to answer that question by sending a value back in. And that value 10 will come in and will replace or complete that yield expression with that value. So now the generator can resume and it can finish its work because it says, thank you for answering my question. The answer to my question was value 10. So now I can add 10 and 1 together and x is 11. From the inside perspective, that's the key perspective you want to have. Don't think so much about what's happening on the outside, because the outside stuff is actually going to end up being buried away in some library. It's the inside stuff that matters. It's what's happening on the inside of the generator. I'm asking a question. Now here I asked a very simple question. I just said yield. I said, give me some value. But what if my question was like making an AJAX call? And I said, I need a response from an AJAX call, and I don't know how long it's going to take, but I'll just wait around until you give me a response. So we could have yielded an AJAX call. Okay? So we've sent an answer back in by way of value 10. X is now 11. We go to line 3. We start executing y equals 1 plus, and another yield keyword. So we're asking another question, which means we're going to pause and wait for that answer, and we're going to return control back to line 8. Line 8 is going to have an object, value, undefined, done false, just like line 7 did. At some later point, we're going to answer that pending question by passing in the value 30 as we're doing on line 10. So that value 30 is going to come back and complete the yield expression that was waiting on line 3. Now 30 can be added to 1, and now y is 31, x was previously set to 11. And now, even though it's confusing with all these arrows, line 4 is going to yield out a value. You see there's a value that I compute, x plus y. It gets computed right away, which is the value 42. So that's me asking a question with the value 42. So I'm going to send out the value 42, and that's why I can say dot value, because I got an object that said value 42 done false. I'm going to run through the arrows at least one more time, because I know it can be kind of confusing. All right? Yes?
At this point, it said meaning, it's printed out meaning of life 42? Or it said...
After line 4 runs, we return the value out, and it would say meaning of life colon 42.
But run is not done yet.
The generator would still be in a paused state.
Sorry, the generator is not done yet.
Which actually brings up a really good point. I'm glad you asked that. Generators do not have to ever finish. It's entirely okay for you to only partially consume a generator, and then when you have no more reference to it, it's just going to get garbage collected like any other value. Okay, so it's entirely okay to do that. As a matter of fact, sometimes you're going to design your generators to never finish. You know how bad it's usually looked at to put a while true loop in your programming? Because while true is like, unless you have a return or a break in there, a while true is going to run forever, right? Actually, it turns out if you put a while true inside of a generator and you have a yield keyword in there, that's an entirely valid design that you actually do pretty commonly. I like to say that generators are putting the while true back into programming, right? Because you might want a generator that every single time you call it, maybe the while true loop, it's going to generate a new unique ID every time. So every time I call next, I get a new unique ID, and then it loops back and it waits again until I ask for another value and another value. That's thinking of generators in the way that where their name comes from, that they are generating or producing values for us. The outside world. So that's thinking about a generator as a producer, and I'm going to consume it by calling .next. From the asynchronous programming world, I've asked you to flip your brains back the other way. So I've asked you to think more about the inside of the generator and not worry about what's happening on the outside. But that's where generators get their name, is that they produce an iterator that can be consumed.
Quick question, why do you put parentheses around the yield keyword? Does that do anything?
Grammatically, it's required.
Okay.
There are some weird grammatics around the yield keyword. So without getting on too much of a rabbit trail there, if you study the ES6 grammar, the way yield is expressed, in this particular case, it's required. So that's an unfortunate nuance of grammar. Yes.
There's a couple questions there saying, what is line 3 waiting for? He thought you mentioned that line 3 is waiting for 10 to finish.
No. So let me run through the arrows again and see if that answers that question. After line 5, none of the generator has started. We have an iterator for it, wrapped with a function we call run, but it hasn't run yet. Nothing has happened. I could have called run, I could have called it step if that helps you understand it better, because stepping is going to step through it one at a time, okay? So we call line 7, we step into it, or we start the running of it. We run the first part of the generator, and that's going to transfer control to line 2. Line 2 starts to execute, runs across a yield keyword and says, I need a value here, I'm going to wait. So I'm going to return control and pause myself while you get ready to answer my question.
So I'm going to run
and I'll wait as long as it takes. In this case, we synchronously have an answer.
So
we're going to send an answer right back in with the value 10. So the value 10 is an actual JavaScript number. There's no specialty to it. It's just a number that we pass in. Could have been a string, could have been an object, could have been anything.
Okay.
It's a value that we pass in, and now it gets added to 1 and x equals 11.
Hold that.
Then we move on to line 3. Don't get confused by the arrows. We're still running the generator.
That we're
on to line 3. We start to run line 3. We have var y equals 1 plus, and oops, there's another yield. So we need to pause again, waiting for control. So we are going to return control to line 8, which would mean that line 8 would get an object back with value undefined done false. At some later point, like line 10, we're going to answer the pending paused question. The yield keyword from line 3 is waiting for an answer, and we're going to give it that answer by passing in the value 30. So the answer to the question is, what is line 3 waiting on? It's waiting on the value 30 from line 10. Okay, that value comes in, 30 plus 1, we now have 31. X is 11, Y is 31. We add those two together, we get the value 42 on line 4, and then we yield out that value 42 back to line 10.
And by the time you give
so it's
me
a pause,
that
resume,
value,
pause, resume, pause, resume. And every pause is asking a question, and every resume is answering the question.
in every pause is answering a question, and in every pause is answering a question. Okay, and in every run is asking a question.
So it's a pause, resume, pause, resume, pause, resume. And every pause is asking a question.
Exactly. And every pause is asking a question, and in every run
And every resume is answering the question.
and in every resume is answering the question. Is answering the question. And in every pause is asking the question. In every pause is asking the questions, and in every resume is answering the questions. So in every pause here is the initial value that you're going to run this. You're going to pass as a URL that you're going to run this promise, all right, with this URL. You're going to fetch that data with this URL, all right? And then by the time that you get that, I want you to yield this, which means that I can pass you now a callback to get the value out of this. Jeez.
Question. Does that make sense? Yes.
So we are paused on line 4.
We are currently paused on line 4, which is okay. We can leave it in that state. On line 12, you could call run again if you want. And you could even pass in a value, and it would go in. And the way we've written our generator, we don't do anything with it. But you could. And you could have a return keyword on line 4.5 if you wanted, and that would return a value. That's all totally valid, but it's not required. You can partially consume this generator if you need to.
So if you just put the while true around that, you could just constantly log the meaning of life. If you
Yep.
just went next, 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 next,
Yep.
next.
Yep, exactly. That's exactly right. Yep.
On line 7, if you pass in, on the first one, if you pass in an initial value,
Yeah.
would it not wait on line 2?
No, that's not what would happen.
One, if you pass in an initial value,
Yeah.
would it skip? Would it not wait on line 2?
No, that's not what would happen. This is one of the not so wonderful parts of the design. As of ES6, if you pass in a value to the initial .next call, there's no yield keyword waiting for it. So that value just goes poof, okay? Which is weird from the outside perspective. It feels like there ought to be some way to get a hold of it, and there is no way to get a hold of it. Many people, including myself, brought up concerns about the inconsistency of that design quirk, thinking that that would confuse people. There's a proposal for ES7 of a way that you would be able to get access to that value, not through a yield keyword. But at the moment, as it stands, don't send a value to the first .next call because it's just going to go. It's an unfortunate, weird quirk of the design. Yeah.
On line 4, if you just do a return of x plus y, wouldn't that finish also?
It would still do the exact same
It would
thing.
do the same. Okay, and then
Then the generator would be fully
complete.
Yep.
Okay,
That's exactly right.
okay.
They're asking.
It would do the same.
Fortunate, weird quirk of the design. Yeah.
On line 4, if you just do a return of x plus y, wouldn't that finish also?
It would still do the exact
It
same
would
thing.
do the same. Okay, and then
Then the generator would be fully
complete.
Yep.
Okay,
The
exactly.
generator will be fully complete.
They're asking in the chat on line 2 if that takes a long time before reaching yield, but then you call run, but a call to run happens, another call to run happens before that finishes. They're asking in the chat on line 2 if that takes a long time before reaching yield, but then you call run, but a call to run happens, another call to run happens before that finishes. What does that look like?
That's not possible with JavaScript single-threaded semantics. It's not possible for you to try to start the generator twice unless the generator from inside of itself tried to call run. And if you did that, you're going to get an error. But it's not possible for some other part of your program to try to call run again, because at any given moment, only one line of JavaScript is executing. This is all still fundamentally single-threaded.
And then they're also following up with like use of a generator. Can you give some real-world examples?
We're getting there with the asynchronous
so
pattern.
we're gonna
Okay? The real-world example I'm going to give you is how this is going to totally magically transform all of our asynchronous programming. But there are other use cases besides asynchronous programming. The most common of which is to produce values, as I was talking about. Flipping your mindset back to not worrying about the inside and worrying about the outside, a generator is just a way to produce an iterator. And if I wanted to iterate through a set of values, I could have my generator sit there and loop and yield those out to me. A generator is a way to iterate over an object, for example. I could have an object that's a data structure with a bunch of values in it, and I could define a generator as my iterator and just yield out all my own values in some special way. So there's ways to use generators as iterator producers. I think that's the less interesting usage of them. I think the asynchronous pattern that we're heading towards is the more interesting usage.
Can you make it immediately invoking to do that first one for you?
Can a generator be an iffy? Absolutely. But you're not going to want to make a generator an iffy unless you store that iterator, because you're going to need that iterator for later. So, yes.
So just kind of clarifying then, they're saying, so the run is blocked until yield.
That is correct. Just that's standard old outside of the generator, everything's the same as it always was in JavaScript. Single-threaded. When a call's running, nothing else can run. The only thing that changes is what happens on the inside, the ability for it to pause. Okay. So let's try to drive more. Keep your mindset based on the inside, and don't worry so much about the stuff on lines 7 through 11, because that stuff's going to end up being plumbing that's hidden away in a library. The stuff we're going to care about is the stuff that's inside of the generator, okay? Here's our meaning of life running example written a little bit more clearly to prove this point about asking questions. Look at line 6. I say x is equal to 1 plus, and then I make an AJAX call, and I yield while the AJAX call is finishing. Okay? That AJAX call, get data, returns me nothing right away. But you'll notice that 1,000 milliseconds after it runs, up on line 2, what do we call up on line 2? We call run to restart, to resume the generator with the value that we got back. So after 1,000 milliseconds, our fake AJAX gives us the response from our AJAX call. And where does that value come back? Right back to the yield expression on line 6. So we get the value 10 right back. So what we have here is synchronous looking asynchronous code. We are able to block locally inside of our generator as if there is some magical pause resume thing, because there is a pause resume now, and it's the generator. The plumbing of the generator is able to pause, wait for some other background thing to finish, and then resume with the value that we were waiting for. So inside of our generator, lines 6 through 11, That's our program logic. That's the stuff we write over and over and over again. Lines 1 through 3 and line 15, that's all plumbing that gets hidden away in some library somewhere. That's the stuff we write over and over and over again. Lines 1 through 3 and line 15, that's all plumbing that gets hidden away in some library somewhere. Our program logic, our flow control, looks like 6 through 11. Now, if you mentally picture that compared to 20 slides ago or whatever, when we went over the promise chains are a form of flow control that ends up vertically orienting a bunch of function calls into a function chain, into a promise chain. And then if you think even further back, we had thunks, and they were nested together, and callbacks, they had all that kind of weirdness. So here we have flow control again. But what's so magic about this particular flow control is that it looks synchronous. Why is that so important? Because that's the way our brains work. We don't have to have any of that overhead, that boilerplate of passing things in as callbacks and chaining things and returning. All that stuff gets hidden away. It's an implementation detail. What we've done is taking asynchronicity itself and factored it out as an implementation detail that we do not care about. I'm not really sure that the full weight of what I just said is actually coming across. That's a huge deal. Taking asynchronicity itself and factoring it out so that we don't have to worry about it. We write synchronous, sequential, blocking-looking code, and we let the library handle all of the ugly bits.
Will I get the same performance like if the get data if it is not making an external call, it's a function in itself and it's making some huge operation? Will I get the same performance like if I do with a web worker or something where I have to do an async?
No. Don't get this confused with threads. Okay? If the behavior is happening in your JavaScript program, it is taking up the single event thread. This is not the same thing as messaging out to a web worker. Could you message out to a web worker on line 2? Absolutely. But line 2 doesn't magically become like a web worker just because you called it from a generator. There's still just one thread for our JavaScript program to run. The only magic that's different here than anything else you've ever written is the fact that lines 6 through 11 get to magically locally block. We've never had that capability syntactically before. And now we have a syntactic way of hiding away all of the complexity of a state machine,
block, bro.
an asynchronous state machine. So our code looks synchronous again. And not only...
Okay, so it blocks this. It's like, hey, by the time you're evaluating, it's like, hey, I'm going to yield this. I'm gonna block this. I'm gonna evaluate this. And when I find a yield keyword, I'm gonna get out of this. Right? And then I'm gonna get out of this with the get data. The question is, are you evaluating is the get data? By the time we call this, because this is now calling is .net.next. So by the time we do this, the question is, so by the time we're doing this, and when we get into the yield, and when we get into the yield, exactly, what in the F is yield doing, bro? It's used to pause and resume the generators. So this will pause and resumes. But by the time you reach to this instruction, yield is say, hey, I'm going to pause, but when? Next is asymmetric. It always sends a value to the current suspend yield, but returns the operand of the next yield. The argument passed to the first next call cannot be retrieved, and there is not currently suspend yield. Description. Okay. So the description, the yield keyword pause generator function execute. The yield keyword pause generator function execution. Jesus. The yield keyword pauses generator function execution, and the value of the expression following the yield keyword is returned to the generator caller. And the following yield keyword, it can be thought as a generator base version of the return keyword. Yield can only be used directly within the generator function that contains it. Yield can only be used directly within the generator function that contains it. It cannot be used within nested functions. Calling a generator functions construct a generator objects, and each time the generator's next method is called, the generator resumes the execution. Okay? So anytime that the next generator is called, initially it's going to run is this one. So by the time you find the yield keyword, a yield expression, in this case the generator pause, and the next method return an iterator result. And by the time you find this, it will now, the yield generator pause the execution and then return that. And then return that. Or produce this get data. And this get data is by producing is calling that. Based on the following image, it is safe to assume that by the time the yield keyword is called, it will call the function, it will call the get data, it will call the get data function. Okay, it will call the get data function, and wait until a .next method is called. The yield keyword here is actually working with coroutines and asynchronous operation, but it's not waiting for the next method call. In this case, get data is a function that uses set timeout exactly to delay execution 1000. The run variable is defined as a coroutine function exactly, and the yield keyword here is being used to wait for the asynchronous get data calls to complete. Oh shit! Fuck! Oh fuck! It's because it's waiting for these functions to be complete, and then it's gonna run that shit. Oh, for French toast, bitch. Because by the time it is called this, it's say, I'm going to wait for this function. Exactly, I'm gonna stop the execution here. Alright? I'm gonna stop the execution here with get data. So each yield is waiting for the asynchronous operations to complete. Exactly. Each yield generation is waiting for that data to be complete, bro. But it's because you are evaluating this sentence here. That's exactly what I want to know. That's exactly what I want to know. So yield expression evaluate. So it is safe to assume that yield expression evaluate and a statement and then pause the execution? Because that's the question here. Exactly. In this context, it is correct. So you now is evaluate that and pause the execution. So by the time next is being called, you answer the question. I'm going to evaluate this. And then, oh my French, those guys. It is safe to assume that the yield keyword is the keyword that yield keyword evaluate an expression, and then only then stop the execution or pause the execution, the execution of the generator. Not exactly. The yield keyword in Python generator actually, but this is in JavaScript, bro. How can I delete this, bro? No, there's no way to delete this. Oh, it's because this is in Python, but I'm talking about is on JavaScript. Not exactly. Let me explain the precise behavior of the yield in JavaScript generator. The yield keyword actually pauses the execution before evaluating the expression. So you are doing is before evaluating. So before evaluate before evaluating that expression. So execution pause before get some value is called. Okay. So this is now pause the execution before this is called. Okay. So this is pause. I paused it. But then some actors actually, okay, but then some actor trigger this. But then some actor trigger this. So then some actor calls me this here. But then some actor called me here that now I have this value that I'm receiving from that. I resume the execution, call this get data, all right, with this value. And now 10, because I received this value here, and now 10, when I get this, when I get into the second call, I get that. It's because it says pause and resume. Pause and resume. So the yield keyword is say, hey, I'm gonna stop stop the execution of this function that doesn't follow the run to completion, okay, these generators, but somebody externally now calls me, and then I resum this, right? And then I resum here. And then I resums here, bro. I resums with now this value, okay, that I'm receiving here from the function get data here. So now someone called me with a value D, and then I go into a value I get data, which is the D value here. What in the French toast is
Not
happening
only does our
here?
regular code look synchronous, our error handling becomes synchronous again. How do we do synchronous error handling? What do we use? Regular code looks synchronous. Our error handling becomes synchronous again. How do we do synchronous error handling? What do we use?
Callbacks?
Try catch. You can wrap try catch around line 6. Synchronous error handling. What do we? So our code looks synchronous again. And not only does our regular code look synchronous, our error handling becomes synchronous again. How do we do synchronous error handling? What do we use?
Okay, synchronous error handling. Try catch.
Try catch. You can wrap try catch around line 6, and if the AJAX under the covers threw some error, that error is going to come right back in and get caught as a synchronous error, because inside of the generator, everything's back to normal synchronous blocking semantics, including error handling. So we get an asynchronous stack that gets normalized back into a synchronous stack inside of our generator. Yeah.
Line 11, console.log answer.
Uh-huh.
Jesus, okay. That'll be all for this video. Take care. Bye-bye.